Hi and welcome to Core Questions, a podcast from the British Geological Survey.
I'm Penny and I'm part of the comms team.
I'm Rose and I work in the public engagement team.
And today our core question is, can satellites see me waving from space? Today we'll be talking with Alessandro Novellino, who's a remote sensing geoscientist. Hey Alessandro, do you just want to introduce yourself and tell us a bit about your job?
Thanks for inviting me. I work in the Earth observation team at BGS, and I use satellite data to map, model, and monitoring natural hazard, with the end goal of saving life.
Oof. No pressure.
Should I drop the mic?
Yeah.
So Alessandro, you came to geoscience in a bit of a strange way, didn't you? With what were you first inspired by?
Armageddon. I need to sue the director of that movie. I thought being a geologist was like being cool, save the planet, sending rocket on space and diverting asteroids. I was wrong. When I first started studying geology, I thought geologists just study rocks on the ground. Why there is a much wider, let's say, application of earth science.
Mm-hmm.
So I have no idea what was remote sensing. I have no module or course on that, even during my PhD.
But question, so because we were going to talk about this actually, how when you say to someone, I'm a geologist, or you say picture a geologist, and you think of people scratching about in the dirt, but you're looking at geology from a totally different perspective, right? From satellites. You're kind of halfway there. You said it was going to be firing stuff into space.
And there is still, honestly, now being serious, there is still a lot of the work we do, of course, require geological understanding of processes. I spend most of the time, sometime looking at satellite imagery, and still to understand what is up, what you see from an image, you still need the earth science.
So let's drill into this a little bit more, because you said you're talking about remote sensing, you're talking about satellites, satellite observation. So tell us, what is a satellite? What is remote sensing or remote observation for someone who's, never come across this before?
Remote sensing is the science of characterizing, understanding an object without touching it. So to do this, we study the way that object interacts through wavelengths. So these wavelengths can be either the optical part of the electromagnetic spectrum, it could be radar, the radar part. And then we have, of course, the optical component of the electromagnetic spectrum is just a tiny bit. So you have microwave, you have gamma ray, X-ray. So different objects based on the chemistry, morphology, size, they interact in a different wave. And satellites are a way, just a platform. So on this satellite, you have this camera, either acquire or also create these electromagnetic waves that interact with the object on the ground. But you can also have this camera on drones, airplanes, so it will still be remote sensing, as long as it's not touching the object.
If we go back to the actual satellites, can you tell me, is it a live feed? Can you, see and direct the satellites? Or do you have to wait and get, are they still images?
So you can control the satellite.
That's cool.
Yeah, you can control. They try, of course, it's, for example, most of the satellite we work with, they are managed by the European Space Agency. I think the office which deals with satellites is in Germany, in Darmstadt. I would be jobless without the European Space Agency data. So that I would say thank you. Can we thanks them?
Thank you, ESA.
Thank you.
Yeah, they control the satellite. There are different elevations. The one we use, there are 700, 800 kilometers above the ground. They are called low Earth orbits. They still travel at a speed of few hundreds, thousands of kilometers per hour.
So because of how fast it's moving, you can't get a live stream.
No, even if there are, I think there are already plans for preparing mission to, for example, recording video rather than image.
Wow.
That'd be cool.
Again, the
Yeah.
challenge is they travel so fast.
So it's not that they're fixed above the Earth's surface; it's that they're orbiting the Earth.
So most of the one we use for Earth observation, so consider we have remote sensing. You have, I would say, most of the satellite you have in space, they are used for meteorological application, and they are fixed. Most of them, they are fixed. They are even for further above our heads. They are like 35,000 kilometers above the ground. They are called in geocentric, so they are essentially they follow the Earth rotation, so they can imagine the same area always. Then you have also the telecommunication satellite, and they most between these two, you have like 80%, 3/4 of all the satellite in space. Earth observation satellite, there are not many. They are a niche, and most of them they move.
Okay.
Usually they move north south.
Why do they move north south?
It's just so that they can essentially see the same area more time, because by the time they go, they complete a cycle north south. The Earth has rotated, so they can see the same area.
Right.
So over time, they lap all of the Earth's surface.
Yeah.
Wow.
They are called their orbit is called sun synchronous, just because they essentially usually they acquire the image at the same time of the day for that area.
That's cool. So, if there's been a massive earthquake, just take us through like a process.
Once the event happen, and regardless of where it happened in the world, we have different web platform, where we acquire satellite data. Consider that over the last few years, with more satellite in space, we have much more observation. This means that we usually, within best case scenario, one day, we can analyze satellite data and provide information like which area has been hit the worst, or which area needs more prioritization in terms of humanitarian support, because NGO rescue services, they are the main end user of our interpreted map. Once they are released online, they are released on website like the Disaster Charter, the International Disaster Charter, and the main driver, the main things during disaster response is time, rather than accuracy. Is providing as soon as possible information that people on the ground can use it.
Wow.
So, look at that. You really are the Bruce Willis of BGS.
I was about to say, you were like,
I hope
I'm a fraud. Like, this sounds like everything you said you wanted to do. Like, disaster response, looking at stuff in space.
Maybe not being on an asteroid.
So we're talking about disaster response there. We produce a hazard map. This is the areas that are most effective. Here's the information. But in remote sensing, would you look at like disaster prediction as well?
Yes, of course. And again, one of the main things is, in particular, Earth observation is, over the last few years, you have more data. And these data are needed because when we talk about machine learning, this new technology, they are data consuming. They need a lot of data, which we didn't have before. Thanks to satellite data, we can, let's say, integrate information we have from the ground. And with that information, we can essentially have better prediction, understanding how, for example, a landslide can behave over the next 5-10 years, more accurate hazard assessment, just because we have more data. But with data comes also a drawbacks, which is you need to store the data, you have to analyze the data. These are efforts you cannot do manually. We are talking about petabyte of data acquired from satellite every day.
Well, a petabyte, how big is that?
Petabyte. So it's 1,000 of terabyte, which is 1,000 of gigabyte.
Wow.
Okay, that's a lot.
And so as a geologist, of course, we still have a key role, because for us, we can let's say, disentangle what's relevant information, what's not relevant.
So we're talking about this, this big petabyte. What resolution are the images that you get from the satellites?
It depends. If you use freely available data set, I think best probably is 10 meter. Of course, if you go in the commercial data set world, they can go also below the meter.
Whoa, what?
Yeah.
Wow.
But consider that when you usually, there is a trade-off. Usually when the resolution is better, so the pixel size is smaller, the area investigated is smaller as well. So you have like, let's say, alpha meter resolution for an area of a few kilometers, while with the 10 meters free data, you can imagine an area of thousands of square kilometers in one go.
So you kind of really need to look at both.
So it depends. For natural processes, for example, we are generally, I would say, happy with 10 meter resolution, because we are looking at large scale processes. We could be, for example, fault trace or tsunami impact. Sometimes 10 meter is enough. Of course, if you're looking more like infrastructure things, is not enough. So single building, bridge. There is, let's say, a portion of this Earth observation satellite. They have a radar sensor, so they operate in the microwave portion of the electromagnetic wave. I will tell you why it's important. They can measure ground deformation from space. Yeah, accuracy of millimeter. So they are used, again, also in civil engineer to monitor bridge, build single building. It's a technology called INSA, which stands for Interferometric Synthetic Aperture Radar.
I knew that.
Yeah, same. Absolutely.
We use that to monitor, ground displacement from space.
That's so cool. Your job is the coolest.
You are saying that to everyone, I think. But consider, by working on the microwave spectrum, it means it's not affected by clouds, which in a country like this make a difference. So regardless of cloud condition, you get an image. So you can measure ground deformation even if it's a cloudy day. And also is an active sensor, so doesn't use the sun energy, the illumination from the sun. This means also at night, you can get an image.
I feel like this is leading quite well into answering our question for today, because we're asking, can satellites see us waving from space? Can they?
So if me and Rose were standing outside BGS.
Coming to your question, no.
Oh, after all that.
Waving from space, no.
But why is that? If they can see to such a resolution, is that just because you're unlikely to be like caught when it's taking an image if it's not video? Like,
But even alpha meter is not enough to...
Surely it is.
I mean, considering you will have everything in alpha meter, it would be 1 pixel.
oh, I see.
How big is your hand, Penny?
Well, my arm's half a meter.
If we got like, say 5 or 6 people to lie on the ground making a hand shape.
Yeah. No, that's definitely, for example, if you have like a sort of, there were a few images, you remember a few years ago when the Capitol Hill...
yeah, January the 6th.
The revolt in the US, and there were some images from Maxa, that's the commercial provider, and you could see the people on the street.
Oh, well, there you go. So if we all stood outside BGS, you'd be able to see us.
It probably could be sort of message if we are together, united as a team.
Oh, I think we need that for our next BGS brochure. All of us standing there, and then Alessandro snaps a picture from space. Perfect. That's the image we need. Right, well, thank you very much, Alessandro. That was an incredibly interesting foray into remote sensing.
Can I say goodbye to Michael Bay from Armageddon in case he see this interview? To call me for the next... They have done a remake of Gladiator. They will do Armageddon as well.
There you go. We'll see you being catapulted into space any day now. Great. Well, Alessandro, thank you very much. That's been a thoroughly interesting podcast.
Yeah, that was brilliant. Thank you so much.
Thanks for having me.